Welcome back. We are moving to the second variation of Black-Scholes model, and actually this is called Black-Scholes-Merton's option pricing model including dividends. This model has implementation is here, all the user inputs are here, and then there is a graph and then there is a table. On the second tab we have formula for calculation of call option price including dividends, and then in the third tab we have the applications. So let us start with the formula. As you see here, the formula for calculating call option price including dividends is C equal to S naught times E raised to the power QT times phi of D1 minus X times E to the power of minus RT times phi of D2. So here basically we are calculating D1 and D2, and d1 is calculated like this, and d2 is calculated here, which is d1 minus sigma and square root of t. So in order to calculate all this, we need the value of s naught, which is current stock price. User needs to enter the value of x, which is the strike price, and then we need to have the value of q, which is continuous dividend yield. T is a time to expiration, in years we will take it, and R is a risk-free rate. When all these things are given, and in addition to that we will also need sigma is volatility of the stock, right? We know sigma in statistics represent standard deviation, but here in finance sigma represents volatility of the stock. Once these inputs are entered, which is here in the implementation tab, when we click it, the user will enter current stock price, strike price, time to expiration. User will select from slider, same way risk free rate, it will be selected from slider, volatility will be selected by the user from the slider, and dividend yield will be selected, which can range from 0 to 20% here. And once these are entered by user, this will be captured in this table. So if user changes something, for example dividend rate is changed to 8%, here the table would capture it, the dividend yield is now 8%. Then down there we have a graph at default values. When the stock price is $100, at other values of these variables and parameters, call option price is $9.23. So there is a table down there also which gives call option price at stock price of $100, as well as other values of S, which is current stock price, which can range from $80 to $120. So this way we have this implementation. So what will happen? The user will enter the values here. App would use this formula for calculating the call option price, and these values will be displayed here, first on the graph and then in the table. And this app is interactive, so user can change the current stock price, maybe T8 here, and definitely when this is changed by user to 88, then definitely here the output in the table would also change, that at 88 the call option price is $3.64. Similarly, the graph would also change and this table would also be updated. The current stock price is just like checking the price of a stock on your trading app, and strike price is just like a future price of buying a thing, but in this case it is the future price of buying the underlying stock. Time to expiration is like time which is left till the expiration of the contract. Risk-free rate is a rate which is risk-free in the sense when you invest it in government security, you are assured a particular rate, and this is that risk-free rate. Volatility is definitely the unpredictability, like the way weather is unpredictable, same way the price of stock is unpredictable, and this volatility is shown through sigma, and dividend yield is considered in this formula. We see that in formula as well, it means company will be paying the dividends, and this is a continuous dividend yield. It is also included in the formula here. So this is the second variation of call option pricing using Black-Scholes model. Please feel free to refer to the previous learning in which we discussed Black-Scholes model without dividends, without considering dividends. See you next time with the next variation of Black-Scholes model. Thanks for joining.